In the previous video, we learned about how you can use the across keyword for writing loops, like the for each loop in Java. However, remember in the contract, like a precondition, postcondition, and class invariants, they are Boolean expressions only. So you cannot write a loop in the precondition, postcondition, or class invariant. It's going to be a compilation error. We might be able to see some demo later in the course. So now I want to show you another use of the across keyword, and that can be used for writing Boolean expressions, which means it's suitable for writing contracts. Let's see how we can do it. Before that, let's set it up. So let's have another Boolean test query at the end. Okay, I'll simply put it here. Okay, let's now call that test quantifications. They correspond to the universal and existential quantification you learned in 1090. So it will be very useful to connect something to the math. So test quantifications, and then it's a Boolean test query, and then I will declare the local variable in a moment. And comments over here, and then let's say, let me copy the query name over here, and then colon, and then we'd say use of across as Boolean expression. So let me emphasize that it's really important. In the previous one, we actually said it's being used as loop instructions. So that means it's used for implementation only. But now what we're doing is primarily for writing contracts. Okay, so now remember the way to invoke the across. The procedure, the first step will be the same. For example, you might simply say across over here, and then you can see it is the S. I would suggest, as I said before, you should always change from S to is. So the difference is, if you change from S to is, now whatever dummy variable you set on to the right of is going to be directly the member of the iterable collection, rather than a cursor to it, right? Review the last video if you have any questions. But now it is this keyword over here we don't want anymore, because loop is only for implementation, but for contracts we want something else. Okay, let me just mention that quickly. Okay, so now what I want to do is switch to iPad and then show you what you should do. Okay, the principle is really the same. I just have to show you, sketch the syntax a little bit so you understand conceptually, and we'll do examples. So now you can see over here, still we have the across over here, and also notice that we have is, okay, rather than s. Okay, so you should really rename the s into is. So what you should do here is you should really put in some iterable collection and then some dummy variable. Okay, we explained it already, and this will be the body of the expression. And let me emphasize that this part over here must be a Boolean expression. Okay, and then the all over here versus sum. So the all over here, that means every member of the iterable collection must satisfy this particular Boolean expression. So that means it corresponds to for all. Whereas every member in this particular iterable collection must satisfy the Boolean expression over here, and some of them, just at least one of them. So that corresponds to existential quantification. Okay. So now, for example, let me just give you one example here. So if I say, in general, if I say for all x, okay, and then I would say x satisfies some predicate. For every x, and then x actually satisfies some predicate. You can think about x is x over here, and then this part over here is to define the p. Okay, that's basically the quantification you learned from 1090. Of course, we had to specify the range of x, and this is where you specify the range of x. And similarly, we do the same for across sum, just the same. Okay, hopefully conceptually you can see the idea. So that you just have to change from s to is, and also you want to make sure you know how to use the keyword for either universal versus existential quantification. That you have to choose the right one. Let's take a look some example to make sure you understand. So let's say the first one I would like to use, let's say we use universal quantification, and I will simply say across, let's say all, right? I want to say for all. Let's say for all, let's still start with maybe the integer interval. For all member of this particular interval, let's say from 1 to 10, okay? And don't forget, to specify the interval is going to be vertical bar dot dot vertical bar. S. So now rather than S, it's going to be is, right? So now is I, or you can just put a prefix to make sure you have no clash. And then you can say Li denotes a member of the interval from 1 to 10. And I want to say every such I or every such Li is strictly larger than 5. Li over here is strictly larger than 5. Logically, is that true? Hopefully you see that's not true, right? What would be the witness for violation? Well, 1, 2, 3, 4, and 5. They are simply not going to pass this particular greater than relationship, right? So the whole thing is going to evaluate to false. But be careful over here. This whole thing here is a Boolean expression, so it cannot stand alone. So you have to assign this Boolean value expression into something else, right? So now we are just checking for this particular Boolean test query, but you may have other purpose for other assignments, maybe for your labs or project. So in this case, I'll simply say result is simply a Boolean value variable. So I'll assign this whole Boolean expression over here to be the result. So let me just indent it a little bit, so actually it's easier for you to see, right? I'm assigning this whole thing directly to result. If you want to make it more comfortable, if you like, you can definitely put a parenthesis over here if you wish, but it's not necessary for this case, so I'll just put it back. Okay, let's say compile, and we know that it's going to be false. And do we expect the test to pass? Well, it shouldn't pass, because if that's false, the last value for result will be false. Did I compile? Let's compile, and then I will, again, I made a huge mistake. I forgot to actually include it in the test execution. Again, you can see it's a very common mistake to make, so please make sure you don't make that mistake. Add Boolean case over here, I'll say agents test, let's say quantifications. Okay, let's compile over here. So now I should expect to see a test failure, right? You can see it's a fail. It's not a check assertion failure. It's simply saying the final value for this result is actually false. So let's go back there. So if you go back there, you will see over here. So this is simply just false. Okay, so I would suggest I'll keep this one here because that's a Boolean expression, and why don't we just negate it? We just say it is not the case. So now I need a parenthesis to say I'm negating. So remember, not it's logical negation. I'm negating this particular this whole Boolean expression. Okay, and then I'm going to just let me copy this guy here, and I know that not the case that every such I is actually larger than 5. What about some of them? In that case, yes, because 6, 7, 8, 9, 10, so they are larger than that, right? So in that case, I would say rather than all, I'm going to say some. Okay, so now you can see that this is not that complicated. Result over here on the left hand side of the assignment is a Boolean variable, and then the whole thing over here is a Boolean expression. How so? Overall, it's a conjunction, and the left conjunct over here is a negation. And the negation is negating another Boolean expression, right? And the right-hand side is just another Boolean expression. You want to get used to writing such sophisticated Boolean expression that will help you write contracts later. Okay, let me compile, and then let me run the workbench system here. Okay, so now everything works. Okay, so that's the first example, and then let's just say check result end. Okay, so that's about how you can use integer interval just to check some basic math. So I'm doing this because it's kind of more or less similar to what you would do in the basic 1090, logic. So just to draw some connection there. So with the across keyword used as Boolean expression, you can reproduce many useful pieces of mathematics that you learned previously. Okay, so now let's do another one over here. Why don't let's say I want to have an array. Okay, let's try to manipulate the array again. Let's say local a of type array of string. Okay, and then let's still try to initialize the array over here. Let's say let me just move it to the center. Let's say a is simply assigned to, let me give you names. Somehow the length of the names are sorted from shortest to longest. Okay, let's say I have Yuna and I have Suyang. And also I have Hyang. So these are the names. You can see Yuna has 4 characters, Suyang has 6 characters and Hyang has 7 characters, right? Somehow the number of characters are sorted. So I just want to show you some, how to use some useful feature for the across. Okay. So now I can say now result, the test result should be, let me just create more Boolean expression to show you. Okay. So now let's say this. For example, I can say across, let's say across, let's say 1 until, let's say over here, a.count. So I'm basically going over every index of array A, right? The indices, the range of indices will be from 1 until a.count. So make sure you change from S to is, okay, just before you forget. And then, by the way, it depends on how you write the across. If you simply say across and then hit enter, it's going to appear like this. On the other hand, if you say across and then space, it's going to be like that. So it's completely up to you which one you prefer. Okay. Okay, let me just keep that there. Okay, let me just use this one line version here just to show you another outlook. Let's say it's going to be li over here. It's going to be an index. So what do I say here? Let's say every name has their length larger than 4, which means the number of characters should be strictly larger than 4. So how do I do that? So so here A is the array of strings, and now I want to give an index. So now in this case, I can say li, right? Similar to the exercise we did previously. So li here, because I'm using is referring to an integer. And now this particular string could be in the first iteration Yuna, or Suyang in the second iteration, or Hyang in the third iteration. How do I know the length of the string? You can look up the string class, but I can tell you it's .count rather than .length in Java, right? .count is strictly larger than 4. Okay, first of all, is this true? Well, apparently it's not true, right? Because Yuna here, the character length is actually 4, so it's not strictly larger than 4. So this will be false. So I would suggest we negate it, right? I'm just showing you how you can do it. Because it's a Boolean expression there, so you can make a compound expression out of it, okay? It's as complicated as you like. How about I do another one here? What about I will simply copy this expression over here, and then I would say, how about just some name has character larger than or equal to 4? In that case, yes, because Suyang has 6 characters and Hyang has 7 characters. So that's fine. Okay, let me also put check result n because I do have more to show you. Let me just compile over here and then let me say run. Okay, everything still works. Okay, so now we also see how you can use the across as the for the interval using to create Boolean expression. I want to show you another one. Let's say we still try to manipulate a, but now rather than just saying, let me just copy this one here. Okay. And I'll show you exactly how I'm going to modify it. Rather than just using indices, if you simply just want to go over every element in the iterable collection one by one, you don't necessarily have to say use indices. So now rather than crossing over the integer interval, why don't I just across A? So now, since I'm using is, so every, let me change a dummy variable as well. So that could be maybe ls. So that's okay, local string, forget ls. So this basically ls is going to be the type of every member of array A, which is string. Okay, that's how I figure out the type. So now let's say ls is going to be a string. So now rather than saying a li, ls, local string. And then I will do something similar over here, and then I'll say across the array of strings, and then every one of them will just be ls. You can choose another name if you wish, as long as you don't have clash. And then ls over here, okay, everything still compiles, and then we should really still work. Okay, so the reason I'm showing you this is alternative. Okay, let's say this. This version over here, version 1, a crossover index set for the array. Let me say valid index set of array A. And version 2, a crossover members of array A. So member is like a content, right? String by string rather than integer by integer. Okay, I want to show you one more. Okay, I want to say, is this array here sorted according to the length of the string? Well, in this case, it is, right? 4, and then 6, and then 7. So 4 less than or equal to 6, less than or equal to 7, right? You know how to do this in predicate logic, so I'm not going to bother you too much on that. So why don't we try? So I'm going to say, let me write it out, okay? The idea is, so now, since we want to use indices to say, why don't I write this mathematically quickly, so you will see, okay? Mathematically speaking, if I have an array A here, and that's pointing to, let's say, you know, some unknown number of elements over here, I want to see that's sorted, right? Let's say integer. So I would say for every I, such that, assuming that start with 1 less than or equal to I, less than or equal to, so this will be a dot count, right? That's the last index. A dot count. It is the case. So these symbols are just my convention. You might be using different symbol in 1090, but that's okay as long as the concept is really compatible. That's fine. So this part is really the range, and then I'm going to say every member over there satisfy the following. Okay. So now I can say A at position I over here, which is referring to maybe some elements, is less than or equal to, let's say, its member. A I plus 1. And now pause the video and think about if this predicate is really correct. Okay? Okay, assuming that you have thought about it, since I'm saying I and I plus 1, what will be the last value for I? The last value for I will be A dot count. So here I plus 1 will be A dot count plus 1, which is already go beyond the array indices, right? So that's not correct. So what I should have said, so this is a common mistake. What I should have said would be A dot count minus 1. Okay, hopefully you can see that, right? So there's a very common pattern here to check to see if a linear collection is actually sorted. So let me go back to my code over here. I want to show you the final example. So result is assigned to, I want to make sure the names are sorted in A according to the length of the string. So let's say across over here, I already know 1 dot dot here. So you might be tempted to write A dot count minus 1. Let me leave it like that. And don't forget to always change from S to is. Is, let's say, L name, for example. And then it is the case that all, let's say, L name, actually that's an L name because it's an integer value, right? It's an index value, sorry. It should be L I, just index, or you can say L index, doesn't matter. Okay, L index. It is the case that A at L index should be less than or equal to A at position L index plus 1. Imagine that if you forgot to actually change from S to is, in that case, you had to say L index dot item, and also here L index dot item. You can do it, that's fine, but just not as convenient. So now if I try that over here, it's not going to compile. It's a very common mistake. That's why I'm showing you again. Okay. So the reason is over here there are two compiler errors, but they're really referring to the same thing. You can read it in detail, but I'm just going to tell you. Okay. It's really a very common one. It's complaining that the way they parse the expression is more like they parse this expression over here and say integer interval minus this particular integer. So there's no subtraction defined between integer and also integer interval, right? Apparently, the way compiler interprets is different from what you intend to do. So in this case, we had to help the compiler. You had to force the way to interpret. So put the parenthesis. Okay, if I put it, and now it will be okay. Okay, again, this is really another common mistake I want to show you. When you do the interval version over here for upper bound and lower bound, if the upper bound or lower bound is more complicated than a single value, like for example, like you're doing like a subtraction, then you have to put them into parentheses to help the compiler. Okay, so let's say we say compile over here, and then let's simply just go for run workbench system. I still actually have failure over here. Oh, I see. The reason is over here I'm only saying the string itself, because I have Yuna, I have Suyang, I have Hyang, right? If I'm only using this, I'm only comparing the string. For example, I'm saying Yuna is actually less than or equal to Suyang, and that's actually not true, because in this case they're doing alphabetical comparison, right? Like a Y is actually larger than S over here. So that's actually not what I intend to do. I intend to say the length of the string should be sorted, right? So now we want to make it a little bit more complicated because that's necessary. So you can see A over here is actually an array of string. And then with the indexing, it's going to be just a string. And now I want to know the length of the string. So I'll say dot count. And similarly, I'm going to say over here, dot count. It's a right neighbor. Okay, save it. And then make sure everything compiles. And now run the workbench system again. Hopefully everything will be a green bar. Yes. Okay, so now let me recap what we have learned over here. So in this particular video here, combined with the last one, let me recap both of them. We are given different options for using across. From the previous video, you can use the across as an instruction for implementation, not for the contracts. For the current video, we'll learn about how you can use the across keyword with all or some to actually specify Boolean expressions. So these can be useful for specifying precondition, postcondition, or class invariants. We'll see some examples later in the video or in the course. Okay, so please make sure you really understand how to use the across notation for different purposes and then practice them.